Okay, here, given the image, we're going to prove that triangle ABD is congruent to triangle ACD. Okay, so I want this triangle, I want to prove that it is the same as this triangle. All right, we have a lot of markings in this picture. Why is AD congruent to AD? Reflexive. Why is AB congruent to AC? Both a radius. Okay. And then it was given that BD and DC are congruent. All right, so we have a reflexive, both are a radius. The other side was given congruent. So by side, side, side. Okay. So we're given this information, JK and JR, and that's actually the first answer. Sometimes the information is just given to you. Okay. Looking at number B, why is JR congruent to JR? We all should know reflexive property. And then more written information. R is the midpoint of KL. The midpoint makes two congruent segments, so why are those two parts congruent? Definition of midpoint. Okay, so the triangles are the same by side, side, side. Using side, side, side a lot today because that's the title of the notes. Okay. So this one, we're going to use some other ones now. Diego bisected DAB. Okay, DAB is this angle here. It's being bisected by this. So two congruent angles by angle bisector. Okay. Okay. This one gives us a lot of information for some reason. It gives us those two sides are the same, those two sides are the same. We also have this middle one by reflexive. Okay, this problem's a little crazy because we can say by side, or we have an angle, we could have said side, angle, side. All right, so this one we just had so much information. That was pretty cool. We could pick what we wanted to do. Okay, we got a problem about a kite. All right, ABC has a measure of angle 100 or 82 degrees. BCD. Okay, so this whole angle right here is 134. Okay, we need to find this angle down here. Okay. We know that these triangles are congruent. Triangles congruent by side, side, side. 82 degrees over here. That means that's 82 degrees. Okay. This 134 is going to be cut in half. So it's actually just 67 on one side, 67 on the other. Okay. Call this bottom angle X. We know two angles. We can find the third. Okay, so that's pretty cool. Using corresponding parts of congruent triangles, the properties of angle bisector, and then just triangle sum theorem. It's pretty cool. Okay. All we're going to do here is true or false. All right, determine if the following statements are true and if their converse is true. If false, you must provide a counterexample. Okay. If two angles, so first off, let's look at this. Two angles are congruent. Converse is you take what's the hypothesis, the first part, the conclusion, the second part, and you swap them. Okay, that's what a converse is. All right, if two angles are congruent, then they have the same measure. That's true. If two angles have the same measure, then they are congruent. So that is true. All right, so that's a strong statement. When a statement is true and its converse is true, doesn't matter how you write it, it's always true, so it's a strong statement. Okay. If two angles form a right angle, so let's highlight that. So the hypothesis is the first part, the conclusion is the second part. We're going to swap them. If two angles form a right angle, then they are complementary. True, because they add up to 90 degrees. But if two angles are complementary, then they form a right angle. That's false. All right, this is a counterexample right here. You got a 30-degree angle chilling over here. 60-degree angle over here. They are complementary, but they're not forming any right angles. All right, this one above, if you wanted to see why it's true, the picture, if you have two angles forming a right angle, then they are complementary. Yes, it doesn't matter what those angle measures are. If they're forming a right angle, they have to add up to 90 degrees. All right, work on your practice problems.